we'll do an activity by folding paper rather, and see what happens in terms of the angles and the shapes that come out as we fold this. So the first step is of course to make a square. So you fold one part of it over like that, and it comes to this side, and you use a scale to tear out that extra bit. Okay, so you end up with a square, and you end up with a square with this diagonal piece, diagonal line that comes over here, the fold that comes over here. So you have that fold in any case, and if you look at this shape, it's a triangle. The base is if the base is pointing towards you, then this end of this triangle and this end of the triangle have the same length. The reason is because you made it into a square, so all of the corners are the same. So maybe I can just mark the corners, these are all equal to each other, right? So when I fold it, then you can say that this side is equal to this side, and therefore you have an isosceles triangle. Not only is it an isosceles triangle, it's also an isosceles right triangle. Why is that? That's because since this is a square, right, the angle over here is a 90-degree angle, and so is this, and so is this, and so is this. So you have 4 90 degrees on each one of the vertices. So if you fold them up now, what you get is a 90-degree there, two sides are equal, and there is a base. Of course, something can be said about these two angles also. So I'm going to let somebody say that. But meanwhile, I'll just write it down. So this is what is called as an, what's the spelling for isosceles? ISOCELES, am I correct?
SCELES.
Correct me?
Sir, between O and C there will be an S.
Between these two, O and C?
Yeah.
ISOSCELES. Is that sounds like quite a lot of letters? Are you sure?
Sir, I'm not sure, I think.
Okay, this is one thing I keep getting confused with. Okay, so this so this is not the correct spelling. This is the correct spelling. Sorry about that. So isosceles. Oops, I think I changed the marker. Anyway, isosceles right angle triangle. Okay, where this side and this side are equal, that's 90 degrees. Did anybody get any insight into what these two angles will be? Any idea what those two angles
45
are?
45 degrees.
And why do you say they are 45 degrees?
Because they are half of 90 degrees.
Because they are half of 90 degrees. And why are they half of 90 degrees? Why do you say they are half of 90 degrees? No, don't think of a complicated answer. The answer is fairly simple. Because you folded them.
it in half.
Yeah, you folded it into half. See, if this end and this end match, the upper end and the lower end, if they matched, that means that the lengths are also matched, right? And if the lengths are matched, that means you have divided it exactly into half. So if you divide the area exactly into half, then the angles also get divided into half. So therefore this angle and this angle are 45 degrees and this angle is 90 degrees. And of course, the proof, one verification, though it's not, you shouldn't call it a proof, verification is 45 and 45 and 90 degrees make 180 degrees, right? And according to Euclidean geometry, the sum total of angles in a triangle will always be equal to 180 degrees. So it looks like that's the right thing. Okay, so here we have to be a little bit careful. So I just want to again compare it to what I did during the workshop. Okay, so this is what I had done during the workshop. So I hold it in the same way, and I can see that this angle is the one that has been divided into 3 parts, not 4. Okay, so now the question comes, how do I trisect this angle? Because bisecting it is easy. I can just fold it like this and I will get 2 halves. But I don't want 2 halves, I want 3 halves. So any suggestions, how do I do that? So you're saying fold it once and then fold again, but then I'll end up with 4. You see, every time you fold, you double the
Oh
double the
yeah,
number of
sir. Yeah.
you
Yes,
double
sir.
the number of angles. So you can't fold it twice. You have to fold it, but you have to fold it in a very specific way. Can you tell how that is done? Yeah, go ahead.
Sir, take the bottom right corner,
Yeah,
then keep it to the like for the top full angle.
like this.
Yeah, like this.
Okay,
Yes, sir.
then what will
So
happen?
then you end up. So then you'll end up with 3 parts.
I don't know where you're going with this. Anyway, I'll try it. Yeah.
So
How?
now when you open it, there will be 3 parts.
How?
Sir, you have to do on both sides, not one. Both.
Like this or like this?
No. Yeah.
Okay,
Now you'll
I'm
end up
going
with
along with
3
what
parts.
you're saying. I don't know. So you got 3 parts. Then
Yeah, you got 3 parts.
no, I want to divide the angle into 3 parts. This angle into 3 parts by folding it like this. 3 equal parts. Okay, let us leave this out for the time being. Okay, so the question remains, you don't know how to do that. I'll tell you how to do that on a rectangular piece of paper. So I've got another A4 sheet of paper. Okay, and I want to fold it into 3. So I need 3 sections over here with each of them having the same width. Okay, so one way to do this is to actually fold it like this. Okay, and it's a little bit, you have to kind of work with it a little bit so that you get it quite right. So anybody who's helped in the house posting letters, so if you had a lot of letters like invitations that you have to send out and you want to put the letters A4 sheets into envelopes, right, then you learn how to do this, because if you fold it like this, then you get it exactly in such a way that it goes into an envelope. So those who have done that, you will know this. So basically what you have to
So
do,
everyone would have done it.
sorry, see, so you
Everyone
see,
would have done it.
huh?
So everyone would have done it.
Everyone would have done it. How come?
So in Sadri we send like by letters only.
When
We
you
send
used to send letters in Sayadri, I think in general, what people end up doing with letters is that they just fold it like this and then you put it in the envelope. Okay, so that's not a nice, neat way of doing it. The better way to do it when you want to put something into an envelope is like this. Okay, but the only thing is you have to adjust it a little bit so that you get these ends of the same length, and so that when you fold it, you more or less get them to the same width. So that is one way in which you can trisect a rectangle, the length of the rectangle, into 3 equal parts. So can you do something similar with this? That's the question. So you try that out, and if any of you succeed, then show it to me and then we will do it together. Okay, so let me try to show you how to fold it into 3, okay, by using the same logic as folding the letter to go into the envelope. Okay, I'm using the same method, not logic, sorry. So what I'm going to do is I'm going to roll this a little bit. Okay, but I'm not going to crease the edge. Okay, I'm just going to keep it folded up, and I'm going to bring this also onto this. I'm not sure if this is the right way of doing it, but it's okay. We are mucking around a little bit. We'll try to figure it out. And then when I am sure that I have got it more or less right, you see that the inner fold goes and touches this edge. Okay, so I'll start again. So what I did was I folded one part without creasing it, and I folded the other part on top of it, and then I picked it up and I adjusted it a little bit. Okay, so that they are kind of aligned. So then I can open it partially folded. I can open it and check it. I have got 3 parts now. Okay, so then I can go ahead and crease it, and I can adjust this a little bit more. Not a great way of doing it, but it's okay. I'll have to live with it for the time being. And now when I open it, I have got 3 parts. So then the next step is to use the scale and then to draw out the lines approximately. Okay, so now I have got each half divided into 3 parts like this, right? And remember, so keeping this information in mind, we know that this angle over here is 45 degrees, right? And 45 degrees has been divided into 3 equal parts. So 45 degrees divided by 3 equal parts will give
15 degrees.
15 degrees to each part.
15 degrees.
So therefore you get, and that is neater. Remember last time when we did it, we got some weird angle, no? We got some 11.5 degrees or something like that. That was not the intended angle. So each one of these is 15 degrees. Okay, so, and of course this side also each one of these will be 15 degrees. And then if you connect these 2 diagonals together, right, then you should be able to figure out all the angles that are there in between. So I have to fold it like this now. So this is again the 2 dots are there, you see. So it's these 2 sides are equal. This is the broadest side, the base. So this is again an isosceles right triangle. This will be 90 degrees. So again this will be 45 degrees. So you can write that over here. Okay. So now the remaining task for you people is label all of these angles. The angles that I have marked over here, label all of them, and I'll give some names to it. This is A, this is B, this is C, this is D, and this is E. So can you name all of that angles, and what about the angles on this side?
Couldn't even the 3 thing, sir.
I beg your pardon?
I couldn't.
You couldn't fold it into 3 parts. Don't worry, Mudit, you need to only approximately fold it into 3 parts. So you don't have to be very accurate, in the sense you don't need to measure with a protractor and find out that the angle is exactly 15 degrees. That's not the point. The point is, if you fold it into 3 equal parts, then these angles will get divided into 15 degrees each. Okay, and then you know this angle is 45 degrees. Can you name all the other unknown angles? So you can answer to me in chat what is A, B, C, D and E, and what about the angles on this side? So you can send the
So it will be
answers.
the angle, right? The degrees of it.
Yeah, in degrees. Yes, correct. So some of you have, a couple of you have sent me the angle information over here by chat, but I'm giving it to you as work that needs to be completed. So please complete the entire triangle. Put all the
Sir,
angles.
sir, will you make an assignment?
Yeah, this will be the assignment. I'll make an assignment for this. So just to tell you at least the answer for one thing. So over here, angle A, how it can be answered is by using this information. You know that according to Euclidean geometry, when you add all the all the angles in a triangle, interior angles in a triangle,
It has to be 180.
it has to be 180. Okay, so you have two interior angles over here taking this triangle. Okay, this angle and this angle are there, only one angle is missing. So the angle A is equal to 180 degrees minus the sum of angle 45 degrees, this one, and 15 degrees. Okay, so that gives you an angle of 120 degrees. So
120.
you can write that angle A is equal to 120 degrees. So similarly, please complete the triangle for all of these angles B, C, D and E, and also tell me what about these. Okay, what about the angles in this side? That's an easy one. If you think a little bit, you will get it. That you don't have to actually do any calculation. You will come to know about it. That's the clue I'm giving you. And then take a picture of this and submit it in the assignment. I'll make an assignment for this by today evening, so you can submit your answers there.